Hello, this video is for the Algebra 1, Chapter 2, Lesson 1, Solving Equations by Adding or Subtracting, where our objective is to solve one-step equations in one variable by using addition or subtraction. The vocabulary for this lesson is equation and solution of an equation. Who uses this? Well, athletes can use an equation to estimate their maximum heart rates, and we'll see that in example 4. An equation is a mathematical statement that two expressions are equal. A solution of an equation is a value of the variable that makes the equation true. To find solutions, we isolate the variable. Remember, variable is a symbol that represents a value that can change. In algebra, it's the letters that we see in the math. A variable is isolated when it appears by itself on one side of an equation and not at all on the other side. Isolate a variable by using inverse operations, which undo operations on the variable. An equation is like a balanced scale. To keep the balance, perform the same operation on both sides. And we've kind of worked with this before in working with properties of equality, the subtraction property of equality, addition property of equality, multiplication property of equality, and the division property of equality. Here we see some inverse operations, addition and subtraction. If we're adding something to x, we can get rid of it by subtracting that value from x. Or if we're subtracting something from x, then we can add to it. So addition and subtraction are inverse operations, and in the next lesson we'll see where multiplication and division are inverse operations as well. Here in our diagram at the bottom, we have a couple scales over here on this left side of it. On the scales, we have two yellow blocks. They weigh the same amount, so the scale is indeed balanced. If we add a red block to each side, notice that we maintain the balance of the scale. That's because what we add to one side, we are also adding to the other, so that maintains that equality. Also on the right side here, if we then remove the blocks, which would be the same as subtracting something from each side of the scale, as long as we subtract the same amount from each side, then we maintain the balance of the scale. Or if we're dealing with an equation, as long as we subtract something from one side of the equation, and we also subtract it from the other side of the equation, then the balance of the equation, or that is to say the equality of the equation, is maintained also. Example 1, solving equations by using addition. Solve each equation. Here in example A, we have x minus 10 equals 4. So let's go ahead and write our x minus 10 equals 4. Right now, the x is related to the 10 through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 10. And what we do to one side, we're going to do to the other. So the negative 10 and the positive 10 interact with one another and create a value of 0, which just kind of makes them go away, and we end up with just x on the left. On the right, we do the 10 or 4 plus 10, and we get 14, so x equals 14. Remember, you can always check your answer by plugging your solution back into the original equation and see if you get a true statement. So here we had x minus 10 equals 4. Well, we found that 14 was the solution, so we will substitute in the solution of 14. 14 minus 10 equals 4. Indeed, that checks out, so our solution of 14 is indeed correct. On example B, we have 2/5 equals m minus 1/5. So let's rewrite it. 2/5 equals m minus 1/5. The 1/5 is related to the variable m through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is 1/5, so we add 1/5 there. And what we do to one side, we're going to do to the other side as well. So the negative 1/5 and the positive 1/5 kind of cancel each other out because they create a value of 0, leaving us with just m on the right. And 2/5 plus 1/5 indeed equals 3/5. Again, if you wanted to be certain, you could always plug that 3/5 back into the equation and see if it is indeed true. And indeed, 3/5 minus 1/5 does equal 2/5. So, also the idea of isolating the variable. Notice how we talked about isolating the variable in the last slide. That is, by isolating the variable, we mean getting it all by itself on one side. Up here in the first one, x ended up all by itself on the left, and on the second example, x ends up by itself on the right side. Let's go ahead and do one of these questions at the bottom. Let's do 1c. So I have 16 equals m minus 9. So the m is tied to the 9 through subtraction. The opposite operation is addition. The number that I'm trying to get rid of is 9. And what I do to one side, I'm going to do to the other. In this case, on the right, the negative 9 and positive 9 are going to cancel each other out, leaving me with just the m. And 16 plus 9 is 25. Now if I plug that back into the equation, 16 equals 25, plugging it in for m, minus 9. 25 minus 9 equals 16. 16 equals 16. Indeed, the solution checks out. Looking at our next slide, we have example 2, where we're solving equations by using subtraction this time. Solve each equation and check your answer. We start off with x plus 7 equals 9. So let's rewrite x plus 7 equals 9. The 7 is tied to the x through addition. The opposite operation is subtraction. We're going to subtract the very number we wish to get rid of, which is 7. And what we do to one side, we're going to do to the other side. The positive 7 and negative 7 are going to interact with one another, creating a value of 0, leaving us with just x on the left. And 9 minus 7 equals 2. We can now go ahead and check our solution by plugging in the value of 2 for x. 2 plus 7 is 9. Indeed, that checks out, so our solution is correct. On example B, we have 0.7 equals r plus 0.4. Let's rewrite that equation here. The 0.4 is tied to the r through addition. The opposite operation is subtraction. We're going to subtract the very number we wish to get rid of, which is 0.4. And what we do to the right, we're also going to do to the left. The positive 0.4 is going to interact with the negative 0.4, and those will cancel each other out, leaving us with just the r on the right. And then 0.7 minus 0.4 equals 0.3. Then here in the check portion, you can see that once that 0.3 is entered in place of the r and we evaluate it, indeed we come up with a true statement that 0.7 is indeed equal to 0.7. Let's go ahead and look at 2c. We'll go ahead and do that one there. 6 plus t equals 14. Well, the t is tied to the 6 through addition. Might look a little backwards this way, right? If we were to write it as t plus 6 equals 14, then it might look a little more obvious that they're tied by addition, right? So let's go ahead and look at this another way. Let's go ahead and think of this as positive 6. What's the opposite of positive 6? Negative 6. So we're basically subtracting 6, or we're adding a negative 6, either way you want to look at it. But what we do to one side, we're going to do to the other side. This is going to go ahead and make those 6's cancel each other, leaving us with t on the left. And 14 minus 6 is 8. Let's go ahead and plug that back in. 6 plus t, which we're saying is 8, equals 14. 6 plus 8 equals 14. Indeed it does. So this checks out. Therefore, we know our solution is correct. Moving along to our next slide, it says, remember that subtracting is the same as adding the opposite. So what they're saying is that if we had 5 minus 3, this equals 2. But if we did 5 plus negative 3, well, this also equals 2. That is to say that subtracting here is the same as adding the opposite, and that's not a very good line through there, of adding the opposite. Instead of subtracting 3, we're adding the opposite of 3, which is negative 3. And so that works out quite well. When solving equations, you will sometimes find it easier to add an opposite to both sides instead of subtracting, which is quite often the way that I personally look at it. For example, this method may be useful when the equation contains negative numbers. Here in example 3, solving equations by adding the opposite, let's solve negative 8 plus b equals 2. So I rewrite negative 8 plus b equals 2. I have a negative 8, so I want to add the opposite. The opposite of negative 8 is positive 8. What I do to the left, I'm going to do to the right. The negative 8 and positive 8 are going to cancel each other out, leaving us with just b on the left. 2 plus 8 equals 10. Therefore, our solution is b equals 10. Now, let's go ahead and do the third one here. And this is negative 11 plus x equals 33. So I have this negative 11. I want to get rid of it, so I'm going to add the opposite. So the opposite of negative 11 is positive 11. What I do to one side, I'm certainly going to do to the other. The 11s are going to cancel each other out, leaving me with just x on the left. And 33 plus 11 is 44. I can check my answer, say negative 11 plus 44 equals 33. Is this true? Well, we've had a lesson before about adding positive and negative integers. We know that if one's positive and the other one's negative, we can instead subtract. 44 minus 11 is 33. And since 44 has the greater absolute value, we're going to use the same sign, which is positive. So 33 is positive, and indeed that checks out. Positive 33 is equal to positive 33. Down here in the lower left, we have a student-to-student note that 0 as a solution. Amma Walker from Carson High School. She says, I used to get confused when I got a solution of 0, but my teacher reminded me that 0 is a number, just like any other number. So it can be a solution of an equation. Just check your answer and see if it works. And then she gives an example here. X plus 6 equals 6. Well, if you you subtract 6 from positive 6 and get 0, leaving it just x, and 6 minus 6 is 0, that seems to check out. If you plug it back in, 0 for x, 0 plus 6 is 6. Does 6 equal 6? Indeed it does. So remember, 0 is a possible solution to some equations. Example 4 is the fitness application that we saw referenced in our first slide. It says when a person's maximum heart rate is the highest rate, in beats per minute that a person's heart should reach. One method to estimate maximum heart rate states that your age added to your maximum heart rate is 220. Using this method, write and solve an equation to find the maximum heart rate of a 15-year-old. So we create the statement here that age added to maximum heart rate is 220. Now let's change that over to math. For age, we'll use an A. For added to, we'll use addition. Maximum heart rate, we'll use the R from the word rate and use an R to represent maximum heart rate, is the equal sign. And then 220, well, 220. So we now have an equation of A plus R equals 220. So we create that equation, A plus R equals 220. Now we substitute 15 for age since they're asking about a 15-year-old. Now we have 15. We're going to add the opposite, or that is to say subtract 15, either way you want to look at it. But we're subtracting 15. What we do to one side, do to the other. 15 and negative 15 cancel each other out, leaving us with just R on the left. And 220 minus 15 is 205. The maximum heart rate for a 15-year-old is 205 beats per minute. Since age added to maximum heart rate is 220, the answer should be less than 220. So 205 is a reasonable answer. Here in the what if, it says use the method above to find the person's age if the person's maximum heart rate is 185 beats per minute. So remember that beats per minute, the maximum heart rate, was actually the variable R. So we're just going to take this equation, A plus R equals 220. Now this time we have a value for R instead of A, because age is what we're trying to find out, right? So we're going to have A plus 185 equals 220. Next, we want to get rid of this positive 185, so let's add a negative 185 or subtract 185, whichever way you want to look at it. We could say that the A is tied to the 185 by addition. The opposite operation is subtraction. We're going to subtract by the very value we wish to get rid of, which is 185, and what we do to one side, we're going to do to the other. the 185 is going to cancel each other, leaving us with A on the left. And 220 minus 185 should be, is that 35? Indeed, I believe it is. So the age of a person with a maximum heart rate of 185 would be 35 years old. Properties of equality. So we've done an activity on this before. We'll go ahead and review that here. So in words, we say addition property of equality. You can add the same number to both sides of an equation and the statement will still be true. If we have 3 equals 3, if we add 2 to both sides, we still get 5 equals 5. In algebra, we would say that if A equals B and we add the value of C to both sides, we still have an equation there. We still have an equal statement. Subtraction property of equality. You can subtract the same number from both sides of an equation and the statement will still be true. So 7 equals 7, true statement. Let's subtract 5 from each side. We get 2 equals 2, and that is also a true statement. In algebra, we say that A equals B, if this is a true statement, and we subtract C from each side, we still have a true statement as well. The properties of equality allow you to perform inverse operations, as in the previous examples. These properties say that you can perform the same operation on both sides of an equation. And finally, we have our guided practice. We'll pick just a couple out here. Let's go ahead and maybe pick 2 and 4. We'll give those a try. 2 is s minus 5 equals 3. Well, the 5 is related to the s through subtraction, so let's use addition to undo it. We're going to add the very number we wish to get rid of, which is 5, and what we do to one side, we're going to do to the other. And so the 5's will cancel each other, leaving us with s, and 3 plus 5 is 8. On the next one, or should we do fractions? Why not do fractions? Let's do number 7. We have 3 over 8 equals t minus 1 over 8. So we want to get rid of this negative 1/8. So let's go ahead and add 1/8 to each side. What we do to one side, we're going to do to the other. The 1/8s are going to cancel each other, leaving us with just t on the right, and then 3/8 plus 1/8 is 4/8. And if we really wanted to get technical, we could say that t is equal to 1/2. That would just be simplifying the 4/8. Next, let's go ahead and erase this so we can get some room for the next section. Sample 2, we'll do number 8, and we'll do number 10 maybe. So we have t plus 5 equals negative 25. T is tied to the 5 through addition. Let's use subtraction. We're going to subtract the very number we wish to get rid of. And what we do to one side, we do to the other. Now remember, we're actually adding a negative 5. So this is like plus negative 5, right? So negative 5, the 5's are going to cancel each other, leaving us with t. And then negative 25 plus negative 5 is going to equal negative 30. Now if we're unsure about that, let's go ahead and substitute that back in. What is that? Negative 30 plus 5 equals 125. No, not 125, negative 25, right? So equals negative 25. Well, negative 30 plus 5, if we were on a number line, we'd be here at negative 30. We're going to go back 5 that way. Then that indeed would take us to negative 25. So that seems to check out. On number, let's see, what is that? Number 10 we're going to do. 42 equals m plus 36. So let's think of adding the opposite. So plus negative 36. Actually, on this one, adding the opposite doesn't seem to work as well. Instead, let's just think about inverse operations. The opposite of addition is subtraction. And we're just going to subtract the number we're trying to get rid of, which is 36, because we want to isolate the variable m. What we do to one side, we're going to do to the other. So we end up with the 36 canceling, and we end up with m. And 42 minus 36, that is a difference of 6, I believe. Yeah, 4 to 40, 2 more. Yep. M equals 6. And as I'm looking at the rest, pretty much a lot of the same stuff there. I think we'll go ahead and call it quits at that. So that's everything that I have for Algebra 1, Lesson 2.1, solving equations by adding or subtracting. Thank you.